Hi there. Let's talk about glycolysis. Glycolysis is universal. What do I mean by this? Well, as you can see in there, it says all cells carry out glycolysis. What are all cells? Well, if you remember from an earlier topic, we talked about the two main cell types, both prokaryotic and eukaryotic. Prokaryotic are those cells that aren't compartmentalized. They don't have a nucleus, they don't have organelles. Eukaryotic cells have a nucleus, they have organelles. Well, both of those cell types carry out glycolysis. Glycolysis, the location it occurs is in the cytosol. And all cell types have a cytosol. So, whether it's a prokaryote or bacteria, or whether it's one of your own cells in your body, both are going to carry out glycolysis. You can do glycolysis whether you have oxygen or not. When I talk about the body needing oxygen to make energy, that's for a later step. Glycolysis doesn't require that. So they can perform this function in both an oxygen-rich, called an aerobic environment, or an oxygen-free, which is anaerobic environment. Glycolysis does require a lot of steps. Again, all of these occur in the cytosol, and let me show you what those steps are. So yes, you do not have this in your PowerPoint. Why? I don't want someone to pull this, look at this, get overwhelmed, and think they have to memorize all this. Now, just to let you know how wonderful it is to be a non-major, if you're a science major, I would require you to memorize all this, because if you're a science major, you're going to see this in so many classes past the first semester that it is pivotal that you start understanding these and knowing these. But you don't have to do that. I do want you to look at it, because if you're like me, being able to see the process will help to explain what's happening overall. And so, as you can see here, and I have my little pointers so that you can kind of follow me as I go through here. This molecule right here is glycolysis. And so you can see it's cyclic. It has carbon here, carbon here, carbon here, carbon here, carbon here, and a carbon here. There are 6 carbons in this little guy. And it also has this little oxygen here. So we've kind of seen this picture using just the line model, and we've talked about it before. This is considered a monosaccharide. It's one sugar molecule, right? And as you can see, what we're going to do is we're going to oxidize this molecule. Now, we only oxidize it partly in glycolysis. We need the other steps to keep taking energy, because we're removing the electrons, and with that goes the energy. And so as you can see, you have a little change here. Here, they all of a sudden put a little phosphate there. Here, the circle looks different. Now we have 5, and it continues to look a little different. Now we have phosphates here too. So I just kind of point this out because there's a lot of change happening and a lot of things moving around in these first few steps. Now, if you look at these first few steps, you'll see 1, 2, and 3, and look at that. Look at the end. ACE, ACE, ACE. Let's just look at 4 through 10, because there are 10 steps in these things, right? And if you look at everything, ACE, 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 and ACE. Believe it or not, there's a lot of ACE there, right? That's because this whole process is mediated by enzymes, which is why we talked about enzymes last time. And we wanted to kind of understand how they work. And so through here, we have all of these different enzymes. And for these enzymes to work and function, believe it or not, for the initial part of this, they need a little bit of energy for this to happen, right? And so kind of how I explain this to make sense is, if you start a new company, most of the time when you start a new company, there's a little bit of financial investment that you have to put to it. Let's say maybe $200. you need to put into the initial investment for your company to go? It's because you need little things. Maybe you need to buy, some space for saving if you're trying to start maybe a computer coding company or something. Maybe if you're trying to start like some kind of t-shirt company, you need to put some money together to buy a silk screener. Stuff like that, right? You need a little bit of money to get things started. Well, in glycolysis, we need a little bit of energy, just like money, to get stuff started. So if you notice in this first series, you have ATP here and ATP here. So essentially, you have 2 ATP that you initially have to invest to get this process started. What's super interesting about this, to continue talking about glycolysis, is that we start with 1 molecule here, but at the end of this, let's look what happens between here and here. You go from 1 molecule here, and essentially there's a meat cleaver-like process that happens, and boom. Now instead of having 1, 2, 3, 4, 5, 6 here, right? You have 3 here and 3 here. So you essentially take this molecule and you cut it in half. Now your body doesn't use this molecule. The shorthand for it is called DHAP. And I always thought to myself, it happens to not work. That was the best way. And it's right, DHAP for short. So that's how I always think. There's 2 molecules and it happens not to work. And so we move to just this 1 molecule, glyceraldehyde 3-phosphate. And so basically with this, there is an enzyme that changes this to this molecule. So from here on out, all the way through to the bottom, you actually have this process happening twice, right? You have it here and it goes through, and then you have it here and then it gets converted to this and it goes through again. So that's how we start with 1 glucose molecule, but end with 2 pyruvate. Now, with that being said, we are going to essentially take and make a couple molecules out of this that are important for not just your body for energy, but to help with later processes to get even more energy made by making more ATP, or adenosine triphosphate. So if you look at this molecule here, immediately you'll see NAD plus to NADH plus hydrogen ions. And so what is happening here? Well, this, if you remember, we don't have a hydrogen, now we do. Leo says grr. NAD is adding hydrogens or electrons there, right? So if you do, Leo says grr, loss of electrons, oxidation, gain of electrons, reduction. So we have a reduction. So essentially what's happening here is in this process, they're taking the energy from this molecule in the form of NADH. So this is basically a electron carrier or an energy carrier. And this happens twice, right? So we're making 2 NADHs from this process. Now, why? Because these NADHs are going to carry those electrons, aka the kind of energy, to the very last process that we know as electron transport to make more ATP. So that's the first thing we have. So we have 2 NAD pluses to begin with, and then we make 2 NADHs. Now, as we go through this, though, you will also see that we make 1 molecule of ATP here and 1 molecule of ATP. So in every glyceraldehyde 3-phosphate we make 2 ATPs. Now, that means, remember, this goes through here twice because we cut this in half and make 2 molecules. So essentially, we are making 4 ATP molecules here. But that's not the net output. The net output is going to be 2. Why? Because we invested the first two. So it's kind of like if at the end of the day, we have our business and we've made $400, right? Well, we made $400, but that's not our net profit because we invested $200 to begin with. So we take the $200 out from the initial investment, repay back the people or yourself that put that in, and then you have a net profit of $200. That's what's happening here, right? You essentially have 4 ADP molecules coming in here, right? But on here, right, that you have those coming in initially as your input, right? And then you're making 4 ATPs, but essentially your net, because you're making 2 here and you're producing 2 here, the net is going to be a little different than what the input and output is. So what I'm going to do here is we're not going to talk about, the only thing we're going to talk about is net output for ATP. Everything else is just going to be how much we bring in and how much we do let go. So let's look at this, and then we're going to wrap up on glycolysis using the picture before to show what the outputs are and the inputs are. So remember 1 glucose, 1 glucose. NAD plus 2 molecules. Oops, apologize. So we have 2 of these, right? We have 1 that goes through here, and then we have another one that goes through here. So NAD plus, we have an input of 2. The input of ADP is essentially 2. Why? Well, you have an ADP here and you have an ATP here. So this, because it goes through twice, is 4. So you actually bring in 4 ADP. Now they say the net output is 2 because you basically release 2 here. So 4 minus 2, right, would be 2. But you actually have 4 ADP that come in. So here are the net inputs, right? That's overall net. So the outputs here, we have 2 pyruvate. I'm sorry, I keep doing that. So here, right, 2, because this happens twice. You have 2 NADH molecules. This is your electron carrier or energy carrier, right? So this right here, it happens twice because you have these 2 molecules. So you have 2 NADHs. And then your final is you have a net output of 2 ATPs. Why? Because your input, your initial input has 2 ATPs here, right? And then you create 4. So your input, 1 molecule of glucose, 2 ATPs, 2 NAD pluses, and 4 ADPs, if you're just looking at overall what's happening. And your overall output would be 2 molecules of pyruvate, 2 molecules of ADP, and 4 molecules of ATP. And I can't remember if I said 2 molecules of NADH. Your net ATP output is 2. So this is overall how glycolysis works. A reminder again, it happens in the cytosol. Everything can do it. And this is going to set us up with the pyruvate molecules that will later feed to their rest of cellular respiration and the electron carrier, NADH, that's needed for the electron transport chain. We will use these 2 ATPs, though, to furnish energy to reactions that need it in the area that you're creating them. So I hope that helps.